In algebra class, you learned how to test for symmetry about the x-axis, the y-axis, and the origin. And we're going to do that again, but now in polar coordinates. So in order to test for symmetry about the pole, and the pole is really just the origin, we check to see if we have the point r comma theta on the graph. Do we also have the point negative r comma theta? So if for every point r comma theta, negative r comma theta is also a point on the graph, then we have symmetry about the pole or the origin. So to check for this, we're going to replace r with negative r in the original equation. And if that resulting equation simplifies to the original, then the graph is symmetric with respect to the pole. Now, if it is not equivalent, we can't conclude that then it is not symmetric, because we know in trigonometry there are different angles that give you the same result. So you might have cosine of some angle, and it winds up ultimately being equivalent to what it is that you're looking at. So all we can decide is, yes, it is symmetric if the resulting equation is equivalent. Otherwise, you just say it's inconclusive. Now, with respect to the polar axis, and that's the positive x-axis here. So if r comma theta, again, is on the graph, then r comma negative theta is also on the graph. So you can see we have that symmetry. And that works whether you're in quadrant 1 and quadrant 4 or quadrant 2, quadrant 3, whatever. So this works regardless. It doesn't have to just work for quadrant 1 and quadrant 4. So my procedure is to replace theta with negative theta in the original equation, and then you simplify. If the resulting equation is equivalent to what we had originally, the graph is symmetric with respect to the polar axis. And again, if it is not equivalent, then we just say it's inconclusive. And finally, symmetry with respect to the line theta equals pi over 2. Now this is our positive y-axis. So if r comma theta is on the graph, then so is r comma pi minus theta. So if here is r comma theta, this point would be r comma pi minus theta. And the procedure is to replace theta with pi minus theta in the original equation. If it's equivalent, then again, the graph is symmetric with respect to the line theta equals pi over 2. And if it is not equivalent, it's inconclusive. So when you do this replacement, this one is a little bit trickier than the other two, because I'm replacing theta with pi minus theta. So if you have sine and cosine, which is what is most likely to come up, then you're going to have to use the sum, or well, the difference of two angles formulas for sine and cosine. So keep those formulas in mind when you're working those problems. And that's how symmetry works.